Hi friends,
Welcome to the world of CUSAT.
today we are going to study the review of circuit elements.
What are the basic circuit elements?
Passive elements are the basic circuit elements.
Passive elements?
Yes, the components which themselves are not capable of doing any type of creative function such as rectifying, amplifying or processing of an electrical signal are called passive components. Without the help of passive components, an active component cannot perform its function. For example, resistor, capacitor and inductor.
Can you briefly explain about resistors, capacitors and inductors?
Okay, first we consider resistor. Resistors are components that add resistance to electric circuits. They are made from low conductance material and come in many sizes and form. The resistor is drawn like this.
What are the common uses of resistors?
Mainly 5 common uses. First one is to establish proper values of circuit voltages due to IR drop. Second one is to limit current. And the third one is to provide load. Fourth one is to control gain. And the fifth one is to fix time constants. The current voltage relationship of a resistor is V is equal to IR. That is, the voltage is equal to current times the resistance. To obtain this equation, the current is going into the positive side of the voltage. So this equation corresponds to this convention where this arrow is flowing into the positive side. And this particular equation is called Ohm's law. The resistance is measured in ohms and the symbol is omega. Next we go on to a capacitor. A capacitor is a very important component which is used in nearly every electronic circuit. The basic purpose of a capacitor is to store the energy or charge and release it whenever desired. The capability of storing the energy of any capacitor is known as its capacitance. Figure shows the symbol of a capacitor. Capacitance is measured in farads.
What is the current voltage relationship of a capacitor?
Capacitor is governed by this differential relationship between the current through the capacitor and the voltage across it. And note again that the convention is to show that current is going into the plus side of the voltage and then we get this equation. The units of capacitors are farad.
Do we use farad specified capacitors in practical cases as well?
The unit farad is too large, so practical capacitors are specified in microfarad or picofarad. Then we get to inductors. An inductor is simply a coil of conducting wire wound on a core or former of some suitable material. Whenever the current through the inductor changes, a counter EMF is induced in it which tends to oppose this change. So the current voltage relationship is V is equal to L into di by dt. Notice that now we are taking the derivative of the current to give us the voltage. The property of coil due to which it opposes any change of current through it is called inductance and is measured in Henry, which is represented as H. And notice again that by convention that the current is going into the positive side of the voltage in order to get this equation.
Can you explain the series and parallel connections of resistors, capacitors and inductors?
For series resistors, you just sum them up. So the total resistance from this point here to this point here is sum of two resistors and is measured in ohms. And the inductors work the same way. The total inductance between this point and this point is the sum of two individual inductances and is measured in henries.
Okay, so in parallel?
Now the parallel connections are a little bit different. Parallel connections means that the resistors are connected together at one end and again at the other end. The total resistance between this is the inverse of the sum of inverses. That is, RT is equal to R1 R2 by R1 plus R2. So then we have got the same relationship for inductors in parallel. So we would also say L1 in parallel with L2 as L1 times L2 over L1 plus L2.
What about capacitor?
Now capacitors are a little bit different. They operate in a different way. The series capacitors has the same equation that we used before when we were looking at parallel resistors or any parallel inductors. So capacitors in series, you use this relationship. The capacitors in parallel are easier. The equivalent capacitance between this point and this point is just the sum of the individual capacitances.
Can you explain about ground in detail?
It's very commonly used, and the ground looks like this. It's a reference for 0 volts. When we look at linear circuits with DC voltages, maybe batteries supplying it, we oftentimes pick ground and say that's one reference node. And reference node meaning that we are going to say the voltage with respect to anything else, any other point in that circuit is that potential with respect to the ground node, and so it's just a reference node.
In case of electronic circuit,
and when we get to electronic circuits, it usually has a little bit more meaning to it, because we oftentimes power these electronic circuits with AC or wall power. You plug it into the wall, and when you plug it into the wall, we are connected to a power system. In that power system, the power that comes into your house usually is grounded, meaning that there is a connection down to the earth and to the real ground, to earth. And so when the power supplies are connected to the wall and then they are connected to your circuit, oftentimes we are required to ground our circuit. So in that case, the grounded oftentimes has a more physical meaning to it, really relating to the ground, the true ground.
what is a node?
A node is anything that has the same potential that's connected electrically together. So every point on here is the same node. Now I might have a different current going through these branches having this node, but the voltage everywhere on this node is the same with respect to the ground.
Okay, can you explain about sources in circuits?
There are two types of sources are there. First one is voltage source and the second one is current source. These two sources are again classified into independent and dependent sources. Independent sources will show us circles and dependent sources have the little diamond shape. All voltage sources have the unit of voltage and all current sources have the unit of amperes.
What is the difference between independent source and dependent source?
The independent source doesn't depend on the rest of the circuit. It's going to be independent no matter what you do to the rest of the circuit. You define a function for that independent source. Now, dependent source, there is a dependence on some other part of it. Now, all voltage sources have the unit of volts and all current sources have the unit of amperes.
For PDF of this session and more study materials, you can join us on Telegram. Thanks for watching.
Have a nice day.